Hello grade 12, so this is chapter 3. We discussed ionic and covalent bonds, and now the third type of bonds happening between different atoms is metallic bonds. Metallic bonds are the reason why metals tend to stay together, metal atoms. So they are hard to melt or hard to vaporize. What happens is electrons are freed from atoms of metals and they are attracted to the nuclei of other atoms of the same metal. So the atoms become more strongly attracted together. Now, then we will talk about intermolecular forces, not interatomic bonds, but intermolecular forces. So different molecules, they also attract with dipole-dipole attraction, which is formed between two polar molecules. So all of these intermolecular forces are referred to as van der Waals forces. So dipole-dipole attraction is a strong force of attraction between charges, okay, partial charges. However, it's not as powerful as the ionic bond that happens between full charges. London dispersion forces is a weak intermolecular force that happens between molecules that are sometimes polar. So they may be usually non-polar, like the noble gases. However, the noble gases, they tend also to remain together, and sometimes they become liquids. Liquids, they have intermolecular forces by definition, by their state, because liquids are together. So why? Because even noble gases or other non-polar molecules, they might become polar because of the movement of electrons inside the molecules. So they attract each other. Hydrogen bonds, you might have heard of them in chapter 1 of biology SAT. So usually they are very important force, intermolecular force in water, in H2O. And they are one reason why water has a higher melting point or higher temperature to become vapor. So here in this graph, you can see the boiling points of many compounds containing hydrogen. So HF and H2O, they have the same molecular mass. However, H2O is much harder, needs higher temperature to become a gas. Why? Because the hydrogen bonds are keeping the molecules more together. And the same if we compare HCl and H2S, which have same molecular mass but different boiling temperature because of the same reason. So here we see in the structures the hydrogen bonds that happen between one hydrogen and of course another element, in this case the oxygen. Okay, it might happen with fluorine, for example, HF. Double and triple bonds, so you already know that covalent bonds might be single, double or triple depending on the types of on the number of electrons shared between two elements, okay, and we can represent them by double lines or triple lines. Okay, so please read chapter 3 until and stop here. Resonance structures that we will cover in the next week. I hope you're having a good time and thank you for listening.